Welcome to 5 Minutes VHDL Podcast, the podcast where we talk about VHDL and hardware design. Since the first episode of the podcast, I've stressed the concept of dividing our project into smaller elements until their complexity is simple to manage. I received a lot of questions in my mailbox. The mailbox is podcast@surf-vhdl.com, and on my Telegram contact that is telegram.me/Francesco_surfvhdl, only a word. The question can be summarized with something like that. Of course, I put the contact in the episode description. The question can be summarized with something like that. Okay, you told us that we have to break down into smaller problems and then connect the various blocks together. But can you please explain to me how to do this? Well, here now I'll try to answer this question. Maybe it will take more than 5 minutes, but anyway. In VHDL, everything we want to realize is defined by an object named entity. But what is an entity? It is all we can design in VHDL. Well, if you think about a microprocessor, the entity will be the microprocessor. How does this be related to the subdivision we talked about before? It is very simple. The entity can contain, guess what? Right, very good, other entities. Well, let's see how to do this. So, coming back to our processor, the microprocessor entity will have inside it, for instance, an entity called arithmetic logic unit, the memory controller entity, the entity interrupt controller, the entity graphic card for the microprocessor that has the video card embedded, and so on. Obviously, each of these entities may have in turn other entity within it. Other entity will represent the partitioning we talked about previously. So, in the link that I put in the episode description, you can find some image that will help us to understand better what I'm saying. In the image related to entity 1, we see an example where we have an entity called N2 with AB input port and C output port. These represent the AND gate on the right. For the second image represent, for example, a multiplier, where we have the entity name mult, entity name mult is port and port description, A and B input port of 8 bits, M the output port of 16 bits. As you may notice, we have defined an object with input and output interface. But if you are an attentive listener, you will have noticed a detail of no small importance. What you have noticed is not enough to give a name that indicates the ports. We must also define the behavior. What do these two entities do? The name is evocative, but is not enough. I remember I had a colleague who gave such evocative names like Mickey Mouse, Donald Duck, Goofy, and something like that to entity and signal inside the entity. As you can imagine, the code was very cheerful, but a little bit difficult to understand. Every time I had to interact with his VHDL code was really a tragedy. So, how do we describe the behavior of our entity? In VHDL, we use the architecture. Every entity shall have at least an architecture associated with it. In some sense, the VHDL allow explaining the behavior of our entity by means of its associated architecture. You can also associate multiple architecture to the same entity. Every architecture will describe the behavior in different way. So, but pay attention, even if it is a feature of the language, I strongly discourage you to do this. Such VHDL code can become very difficult to understand. In this podcast is aimed at giving good design rules, so we leave all the esotericism to the virtuoso of the VHDL code. Always remember what Newton said. Truth is ever to be found in simplicity, and not in the multiplicity and confusion of things. So a fundamental design rule is one file for each entity and one architecture for each entity. And the file name is the same as the entity name. You will see that following these simple rules, the design will become definitely simpler. Okay, coming back to our entity, we say that to each entity we associate a single architecture. If you go to the third figure, an example, we can see another example. The entity 3 has the same interface of the entity 1. It describes an N2 port with A and B input port and C the output port. In this case, we associated the architecture RTL. The syntax is architecture is a keyword. RTL is the name of the architecture. You can call it Mickey Mouse, Goofy, or what you want. RTL is the name of the architecture related to the N2 entity. In fact, we have architecture RTL, of is another keyword, N2, that is the name of the entity, is keyword, the declarative part of the architecture that is empty, then the architecture description that starts with begin and terminates with end RTL. Inside we have the description, the behavior of the entity 2. In this case, C, output port, less equal A and B. This is the entity behavior of N2 entity. In the episode description, I put the link to the VHDL file of this example N2, if you want to take a look. In this episode, we have seen how the VHDL allows us to create functional block through the entity. To describe the functionality of an entity, we associate an architecture in which we insert the functionality of the entity. We describe the functionality of the entity. The rule of the good VHDL designer is one file for each entity and one architecture for each entity. The file name is same as the entity name. For today, I think it is enough. We take much more than 5 minutes, and I hope you will forgive me. Remember to subscribe the Telegram channel if you have not already done so. In the episode description, you will find all the reference to contact me if you want to go deeper into something or just to give me a feedback. Every feedback is appreciated. Last but not least, don't forget to make your review on iTunes. If you put 5-star is better. This helps me to make the podcast visible to other people. Okay, see you in the next episode and ciao.